Right. Take a fresh page and put the heading London equations. This is very important. Listen, please. London equations. Right. Ready? Right. So what are these London equations? Why we are discussing this? In the last class, we have discussed this Meissner effect. What is this Meissner effect? The magnetic field inside the conductor is becoming 0. That means it is decreasing. Initially it was there, but after some time or after traveling a certain distance in the superconductor, the magnetic field become 0. So this is the big difference between normal conductor and superconductor. So once again, what we have discussed in the last class, Meissner effect or Meissner effect, whatever it is, Meissner effect. 1 minute. Now whenever you have a superconductor, so earlier we have that magnetic field, external magnetic field, but the magnetic lines of force are pushed out of this material, superconducting material, something like this, and finally we got the magnetic field inside is equal to 0. Why? Why this is happening? What Maxwell says, what Maxwell's equation says, rate of change of magnetic field induce electric field, rate of change of electric field induce magnetic field. Why it is becoming 0? The Maxwell's equations are not sufficient to explain this behavior. Why? The magnetic field is becoming a 0 inside the superconductor. Okay. So this, to explain this, Maxwell's equations are not sufficient. Maxwell's equations are not sufficient. We need another set of equations called London equation. Okay, let us start. This is the superconductor. The superconductor contains two types of electrons. One is normal electrons, another is super electrons. So what is the explanation they are giving? Listen. So here we are investigating what is the reason for the magnetic field becoming 0 inside the superconductor. Means magnetic field is decreasing. How it is decreasing and why it is decreasing? Okay. So the superconductor contains two types of electrons. One is a normal, another is a super. What is this normal electrons? So whenever these normal electrons are flowing, that is the current flow. So definitely they offer resistance. Say yes or no? Resistance. That means there exists a resistance. So the resistance is not at all equal to 0. But super electrons, if these electrons are moving, there is a current flow, but unfortunately for them resistance is 0. The resistance in the flow of super electrons is 0. And here they obey Ohm's law, but unfortunately here they does not obey Ohm's law. Does not obey Ohm's law. This is the difference between normal and super. Okay, fine. Now here we are discussing the dynamics of super electrons. Dynamics of super electron. Because there is no issue with the normal electron. Maxwell's equations are there. So we can explain the dynamics of that normal electron by using Maxwell's equations. But here the problem is with the super electron. Okay. So if you want to get the dynamics, I hope everybody know, mass into acceleration is nothing but what? Force. Okay. So I can write this m dvs bar by dt. I hope why I am using this s, you know, yeah, super electron. So this is nothing but force. What is the force here? E bar. Say yes or no. Which one? Minus. Because the charge is what? Negative. Okay, so this is the Newton's second law, m dvs bar by dt equal to minus EE. Any doubts? Okay, 1 second. Sir, which electric field? Electron is moving in the lattice. Na? In the lattice, positive ion course. Is that clear? Right. Now, okay, so I hope everybody know the current density formula N E V D generally for electron. But here we are talking about the super electron. Charge is minus, okay, and this Vs bar. Is it okay? Now this N also I am taking it as Ns, where Ns is the concentration of super electron. Okay, J is equal to minus Ne Vs bar. So I can write Vs bar equal to minus J bar by Nse. With your permission, I will take it and substitute here. Then it implies, okay, minus outside, J bar, okay, minus J gets cancel, and here M, J bar, M, 1 minute, 1 minute. This is what? M, okay, minus M by Nse into dj bar by dt equal to E bar. Is it okay? Is it okay? Is it okay? That's it. So finally I got one equation. Come on, say yeah, M dj bar by, sorry, M by Ns E square dj by dt equal to E bar. This is called first London equation. What is this? First London equation. If you want, you can bring that side also. What is that? Dj bar by dt equal to Ns E square by M E bar. That's good. This is the first London equation. Come on, write down. So Maxwell's equations are not sufficient. That's why we are going to define the new set of equations called London equations. Finally, we got the first London equation, that is dj bar by dt equal to Ns E square by M into E bar. just we are checking the dynamics of these super electrons, and just a simple, we have taken Newton's law, nothing else, and after that current density formula we have taken, just we replaced the velocity, and we got a relation between J and E, dJ by dt equal to ns E square by m into E bar. So this is the first London equation. Don't simply copy, substitute, you know all the things. J equal to NEVS, you know, get the Vs and take it and substitute. Minus minus gets cancelled, and finally we got a dJ by dt equal to ns E square by m into E bar. Ready? Are you ready? Is it completed? Stop. Okay, fine. We got this equation and we are taking this as the first equation. Wait. Now, please consider the Maxwell's equation, that to Faraday's law. Please consider the Faraday's law. Wait a minute. Faraday's law. Sir, why you are considering Faraday's law? I told you ultimately we have to get a relation how the magnetic field is decreasing. I have taken a Faraday's law. Come on, say what is Faraday's law? Del bar cross E bar equal to. Cool. Can you please take this E bar and substitute here? Because E bar can be written as, wait, E bar can be written as m by ns E square into dJ bar by dt. Now wait a minute. This is a del bar cross ms by, sorry, m by ns E square dJ bar by dt. This is equal to how much? Minus dou B bar by dou T. Many times I told you, you can always interchange space and time operations. That's why I am going to write this d by dt of del bar cross m by ns E square j bar. Say yes or no? Okay. And I can write this constant also outside. So then it is m by ns E square d by dt of del bar cross j bar. Is it okay? Because this everything is a constant. That's why simply I have written outside, and it is equal to how much? Now please compare on both sides. This is the time derivative. This is also time derivative. What is the remaining here? And here remaining. Ready? Come on, say B bar equal to minus m by ns E square del bar cross j bar. Cool. Or else I can write this. Del bar cross j bar equal to, hello, j of what? Super electrons. Okay, na? Don't forget this. If you want, you can write super electrons. Equal to minus ns E square by m into B bar. Wait a minute. That's it. I think this is called second London equation. That's good. Now wait a minute. Okay, fine. So what is the second London equation one more time? Del bar cross j bar equal to minus ns E square by m into B bar. Very few people are saying. What is the first London equation? dJ bar by dt equal to Listen carefully because we have less time to prepare again and again. You have to concentrate more in the last topics, but our amplitude is decay, attenuating. That's why we won't remember. So, yeah, definitely you have to remember. Okay, we have derived and you have to remember that relation. If you not, how you will do this? Next, second equation, del bar cross Js bar equal to minus Ns E square by, see, rate of change of current density Ns E square by M electric field, curl of J bar equal to minus Ns E square by M B bar. Please try to remember like that. Because this factor is same. For first equation it is a plus, second equation it is a minus. And here it is first equation, rate of change of J with respect to time. Next one is a curve. At least remember. Oh, sir, we know one relation. What is that, Babu? Sir, B bar equal to del bar cross A bar. Oh, super. One more relation we are getting. JS means a super electron current density. This is nothing but del bar cross minus Ns E square by M into, I hope you got what is a JS bar. The current density of the super electrons is given by that's it. Okay. Sir, what is this Ns? This is the number of super electrons. Number of super electrons. Yesterday, just I told you what is the relation. This is total electrons. That means total electron means super plus normal into 1 minus T by Tc whole power 4. Please, please don't forget this. Right. One is dj by dt, another is a curl of j. So one is related to electric field, another is related to magnetic field. That constant is the same, but one is a plus, another is a minus. M by ns e square, sorry, ns e square by m. Ns e square by m. Ready? Ready? Yeah? Right. Now listen. Again, what is your aim? You have to know the reason why the magnetic field is decreasing, or how it is decreasing, or how it is varying, we have to know. But we know already a superconductor, electric field inside is what? Zero. It's a conductor. For a normal conductor or superconductor, electric field is what? Zero. Already I have taken Faraday's law. One more law is there, Ampere's law. What is that? Del bar cross B bar equal to mu naught J plus 1 by V square or 1 by C square dou E by dou T. That E is gone already. So then could you please tell me, understand what I am saying? Ampere's law. What is Ampere's law? Ampere's law. Del bar cross B bar equal to mu naught J S. Here I am using the word S for super electrons. That's it, nothing else. Okay. So del bar cross B bar equal to mu naught Js. Shall I apply curl on both sides? Apply curl on both sides. Come on, say del bar cross del bar B equal to. Good. I hope you know what is a del bar cross B bar. Del of del bar dot. Okay, equal to mu naught del bar cross Js bar. Okay, everybody know del bar dot B bar equal to 0. Then finally, del square B equal to, I hope you are observing, this is mu naught, and this is London's second equation. First equation is dJ by dt equal to ns E square by m E bar. Second equation, curl of J contains B. I hope now you got the relation for B. Minus ns E square by m B. That is what? Right. This is from London's second equation. Del bar cross Js bar equal to minus ns E square by m into B bar. That's good. Okay. So these two minus gets cancelled, and finally I got del square B equal to, or shall I bring this minus this side? Yeah. Come on. Mu naught ns E square by m into equal to. Now I am assuming this as 1 by lambda square. 1 by lambda square. I told you yesterday lambda penetration depth. Del square B, anything I can take, just I have taken 1 by. In Schrodinger equation, what you will take? A k square. Come on. 1 by lambda square B equal to 0. It's quite similar to your Schrodinger's equation. Del square plus a k square, or del square minus a k square. Del square plus a k square. Then the solution is exponential or sinusoidal? Sinusoidal. Del square minus. That's it. So the solution. This is, I hope everybody understand. Some A e raised to. This is a space. I am taking one dimension. I am taking one dimension. To understand only we are doing. Come on. Minus x by lambda. Shall I do it? Yes, sir. Me bonda. Right. A e raised to minus x by lambda plus B e raised to plus x by lambda. Any one of the solution. Actually, this is the general solution we have written. Here we are studying about the magnetic field decrease or increase. That's why this equation, this solution does not exist. So only this one. So finally, now say B of x equal to, with respect to position, some amplitude I am taking B naught, e raised to minus x by lambda. Oh. The London equations are giving you a result how the magnetic field is varying with respect to space in the superconductor. It is decreasing exponentially. This is your question for set exams. The magnetic field varies exponentially inside superconductor. Okay. So finally what is happening, sir? Right. Now for example, this is the surface and here we have superconductor. This is the surface of the superconductor. At the surface you have the amplitude how much? B naught. So here you have some, that means it is a traveling inside the superconductor. This is the superconducting material. It travel a distance, let us say lambda. How much distance travel? Lambda. After traveling a distance lambda, the magnetic field amplitude B becomes B naught e raised to minus 1. That means how much? That means 0.37 of E naught. I don't know how many of you are observing. So the amplitude become how much? B naught by E. So what happened here? The amplitude. So earlier we have B naught, but it is a keep on decreasing. The amplitude is keep on decreasing. Something like this. So what is this distance? This is the distance at which the amplitude become how many times? 1 by E times. And this distance is called London penetration depth. This is called London penetration depth. So what is a London penetration depth means? If you take a superconducting material, on the surface its amplitude, magnetic field amplitude is B naught. But once it enter into, means if you travel a distance x equal to x equal to lambda inside the superconducting material, the amplitude become 1 by E times. That means finally the magnetic field is decreasing inside the superconductor. So this equation can explain theoretically how the magnetic field is decreasing. Experimentally they found, of course. And could you please tell me what is the lambda here? Already we have defined 1 by lambda square equal to how much? Mu naught ns E square by m. Now could you please tell me what is the lambda? Lambda reciprocal m by mu naught ns E square whole power. Now this is your one of the most important question. London penetration depth is proportional to under root number of super electrons. M constant, mu naught constant, E square constant, number of super electrons vary. That's why the penetration depth is proportional to. Now I have taken this is iron, normal conductor. Any super electrons you have? Super electrons ns is equal to 0. Then lambda equal to that means after a infinite distance only magnetic field is decreasing. Means what? In a normal conductor magnetic field never be 0. See, these equations are how explained the nature of normal conductor as well as superconductor. Is that clear? If you are interested, please write that. If ns equal to 0, this is for normal conductor, ns, no ns. That's why for normal conductor, lambda tends to infinity. What is the meaning of this? Magnetic field never be 0 for normal. Don't simply copy, you know Ampere's law, everything you know, just substitute and you will get a quadratic equation. Sorry, you will get a differential equation. I am not giving any definition. If you are interested, right? London penetration depth means the distance inside the semiconductor at which, superconductor at which the magnetic field amplitude becomes 1 by E times initial amplitude. And one more equation I am writing here because there is no space. I am writing here. Please write this also. Lambda at a temperature equal to lambda of 0 1 minus T by Ts whole power 1 by 4. I think something, yeah, whole power minus 1 by 2. I hope you know why it is minus 1 by 2. Because ns relation given there and lambda is inversely proportional to root ns, I mean inversely proportional to root ns. That's why it is a whole power minus 1 by 2. Please focus on SM and electronics. Those, if you are neglecting those two papers, you will be out of the field. Do you know what are the changes already implementing from next year onwards? No student can do PhD without entrance exam. Till now in your universities, Abhay, Osmania, ఇప్పుడు అక్కడ ఉన్నారు చూసావా, వాళ్ళందరికీ పాపం చుక్కలే. ఎందుకు? దే విల్ డూ డబుల్ పిహెచ్డీలా. నై, ఎనీ పిహెచ్డి ప్రోగ్రామ్ వితౌట్ రిటర్న్ టెస్ట్ అండ్ వితౌట్ ఇంటర్వ్యూ, నో యూనివర్సిటీ షుడ్ గివ్ రీసెర్చ్, I mean PhD admission. Two types of exams are there. I will explain, just write down. 2022 to 2023 onwards it is implementing, next year onwards. And surprising thing, get ready, BSc 4-year degree students are also eligible to write your exam. Yes, 4 years degree, because you have 3 years degree. So competition chale gayi. Matlab MS, not only MSc students, BSc students also going to write the exam with 7.5 CGPA only. If they don't have 7 CGPA, they have to do one more MSc course of 1 year. Not understood? So please try to clear this year only. Next year, we don't know now how many people are interested in BSc. Definitely number will be increased, no doubt. BSc honors people na. BSc honors means last year, final year, what they will study? Physics only. So definitely they will write along with you. Now onwards, next year onwards, we won't hear these words. My guide called me, my professor called me, please come and do research under me. No, these type of sentences you will hear. Okay, sir. Then this year only we will go and do it. We will go and join. But without JRF, don't do any PhD. One more time I am saying. India is changing. That ministry is clearly saying that statement. We want to encourage more students towards research and development. That's why we are doing like this. Right. So that's it. And finally, we have understood why this magnetic field is decreasing. So this is important, Amma. The magnetic field inside the superconductor varies exponentially, decrease exponentially, okay, decrease exponentially. And what is the London penetration depth formula? Remember. So lambda equal to m by mu naught ns e square whole power 1 by. So lambda is inversely proportional to root ns. If ns is 0, then a lambda is infinity. That means magnetic field never be 0. That is for a normal conductor. So the Meissner effect is decreasing the magnetic field inside is because of the presence of super electrons. Have you seen? Anybody seen those things? Theoretical explanation. Two types of things will be there. One is experimentally what we observe. We have to explain by using theoretical. So two different things, but explain the same. Right, listen. I will tell you briefly what this UGC is saying. Maybe at least you will be having an idea. Listen, this is from next academic year onwards. They are going to implement this from next academic year. Academic year means 2022 to 2023. Listen, actually what they are doing is, here is a BSc, undergraduate. This undergraduate program, for you it was 3 years. Now they made it a 4 years program. I feel it is just like honors. Just I am thinking. Maybe first 2 years a common subject. After that electives will be there, and whatever you want you can elect, something like that. And one more advantage what they are doing is, for example, you join in a BSc course next year onwards. Maybe if your sisters, brothers are there, please tell them. You joined in a BSc course. Earlier how it was, for example, you studied 1 year and you discontinued due to some reasons. What will happen? Again you have to take the admission for the first year. And here it is not like that. If 1 year is completed, you can take the certificate and go. After 2-3 years again come back, join anywhere and continue the second and third. Again go and come back and do the 4th year. This is what they are doing. That means no student should lost the year. That is what they are doing. Some problems came, who knows what will happen in the future. So that's why they did. Every year you will get a 1 certificate. If you want to continue, continue. If you want to go, go. So anyhow, okay, so this 4 years is a 4 years program. Listen. And here M.Sc program is there. This is the post graduation. This is 2 years only. M.Sc program 2 years. I will tell you what is that 2 years. Ready. So in this 4 years, they divided 2 categories. Those who have done 4 years course successfully with 7.5 out of 10 CGPA. All these people are eligible, only these are eligible to write a national wide exam, NET, or a common research entrance test, conducted by all the universities, or a state level set exam. That's why your states didn't announce any set exam. So they are going to change that a set exam combined for both research program also. Earlier it was only for lecture. See, still so many changes are there. I hope you understand this. Only these people who got CGPA can write this exam, eligible to write the exam. They didn't get. Let us say they didn't get. Then what they have to do? They got less than 7.5. SC/ST candidates, they have given 0.5 concession or discount or something, 0.5. Other people 7. Less than 7.5 you got. Then what you have to do, you know? You have already done 4 years And those who got less than 7.5, they have to do 1 year M.Sc course and then write NET. And a punishment. If you didn't study well, you got less than 7.5 CGPA, you are not eligible to go for PhD. You have to do again 1 year M.Sc, only 1 year. Year is not losing. I hope if you observe carefully, there is no loss of year. 3 years there, 1 year, and here 1 year, total 5 years. So 1 year M.Sc and they will come back to again this one. And here one more twist they have done, they made. Up to this, is it okay? Then what they have done, PhD admissions are must admissions, must through written test. No university is allowed to take the research scholar without any exam. So 2 types of exams they are conducting. One is a NET, another is what? SET, CRET, something like this. Listen, in the university, if you have 100 seats of PhD admissions, 60% must be given to NET qualified students. You should not give as per your wish. 60% of the research admissions must given to the NET qualified students. For them, there is no again one more written test. For them, there is no one more written test. Directly they will go for interview. They will go for interview. In this interview, if you clear JRF, 10 marks will be added in the interview. If you clear LS, 5 marks will be added in the interview. So, I hope now you understand the importance of JRF. In the interview itself, they are giving 10 marks to the JRF candidates and 5 marks to the LS candidates. That's it. And after that, remaining 40% seats, me karma. And they left to that universities. But conduct exam, conduct a written test and take. That too, what they have done this 40% seat, 70% weightage to the written test, 30% weightage to the interview. Again, I hope you understand what I am saying. So that is what they have done. Because many people will qualify now. So again, 70% based on the marks in that written test and 30% based on the interview. And here for them it's not like that. No 70, 30 something. Already those whoever cleared the NET exam, LSA, JRF does not matter. Now onwards, anybody can do research. Understand? Earlier only JRF candidates will get the stipend. No. Now LS also you can apply for research. But only 5 marks is the difference between LS and JRF. Understand? Very important, Rasama. Next year onwards, everything is changing. Right. So this is the change going to come in India next year onwards. So what you will say to your brothers and sisters? Don't go to M.Sc Physics. Huh? No, any course, all degrees, all courses like this only. Even arts, everything. వాళ్ళు ఈ యూనివర్సిటీ వీసీలు అంతా దే ఆర్ మొత్తుకున్నారు అంటే దే ఆర్ రిక్వెస్టింగ్ ఎవ్రీబడి ఈజ్ డూయింగ్ దేర్ డబుల్ పిహెచ్డి ట్రిపుల్ పిహెచ్డి లైఫ్ లాంగ్ పిహెచ్డి దే ఆర్ ఓన్లీ మ్యారీయింగ్ దేర్ చిల్డ్రన్స్ ఆర్ గోయింగ్ టు ద స్కూల్స్ దే ఆర్ ఓన్లీ దిస్ ఈజ్ హ్యాపెనింగ్ సో ఐ థింక్ ఫర్ ఆల్ దోస్ థింగ్స్ మేబీ నెక్స్ట్ ఇయర్ ఆన్వర్డ్స్ దే విల్ గివ్ full stop. So I hope you understand what is the importance of this. And there is one rumor, you should know this. Actually, some YouTubers or something like that, they are saying that for doing assistant professor job, NET is not compulsory. It's wrong. What UGC said, you know, for example, there is a experienced person, and he is a source of knowledge. How to utilize that person services? Then what they are saying is, although that experienced person is not having any NET or PhD, the universities can hire that person for the teaching. This is what they said. If that person is having experience of teaching and experience of something and subject, then you please take him for the teaching assistance without NET or without PhD. So these people without NET, without PhD, assistant professor is allowed. Not all, only some sources, because some services will be there. Do you know, already in IITs some professors retired, then also they will use their services. Still they will be with the IITs only. They are not permanent or something like that. Like that, you can use any person's service who is suitable or who is eligible. This is story of studies, our research in India. Right, that's it. Now come back. Now please put the head subheading. Isotopic effect. So please take the subheading. Isotopic effect. Isotopic effect. Write down. Actually, I have to give this yesterday itself. I think somewhere, 1 minute. Yeah, isotopic effect. Write down. The critical temperature for a superconductor varies with isotopic mass, that is, the critical temperature for a superconductor varies with isotopic mass, that is, Tc m power 1 by 2 is constant. That means Tc and root m is a constant, anything. Tc m power 1 by 2 is a constant, where m is what? Isotopic mass. Isotopic mass. Write along with me. Next point. This is similar to Debye model of phonon spectrum. This is similar to Debye model of phonon spectrum, that is theta d, Debye frequency, you know that, theta d and root m is also constant. Theta d into root m is also constant. This is quite similar to, they found any similar expression is there. Yes, the Debye model theta d into root m is also constant. Next, that is finally Tc proportional to theta d proportional to, we can say, m power 1 by 2. Minus 1 by 2, sorry. Minus 1 by 2. Write down. That is superconducting transition. That is very important, Amma. Superconducting transition depends upon the mass of the lattice ions. The mass of the lattice ions depends upon the mass of lattice ions, that is electron-phonon interaction is an important factor for the superconductivity. So this gives a hint The electron and phonon interaction is a very important phenomena for the superconductivity. That's why we got the BCS theory idea. What is that BCS theory idea? Electron-Phonon Interaction. So what is the evidence for that means this one. So here we got this one and Debye model also satisfying this one. So definitely there should be a relation between them that will explain the BCS theory. Right, wait a minute. Second point. Now for example, you have a superconducting ring. Am I important? Superconducting ring, let us suppose. Okay. So here we have B external magnetic field. Okay, as usual. And then what will happen? The magnetic lines of force will be developed inside this superconductor. Now I am taking the flux, just like this. I am taking the flux. So here we have two types of magnetic fields. I hope everybody know. The total magnetic field is equal to the magnetic field induced or inside, is it okay? Plus the magnetic field external. Say yes or no. So this is the magnetic field, I will say inside the superconductor. This is what you have applied the external magnetic field. Remember, this total magnetic field, I repeat, always quantized. You got a doubt. Sir, how it is always quantized? Carefully observe. What you are applying? External. Anything you can apply. We can't say that is quantized. And we can't say also because it's a simply rate of change of magnetic field. We can't say it is a changing equal amounts. If it changes equal amounts, go in the zero. So that's why there is no scope of equal amounts of change in external magnetic field. Then what is left? This one, magnetic field inside the, listen, the magnetic field inside the superconductor always adjusts itself such that this total magnetic field is always quantized. There is no scope for the quantization of external magnetic field because it is a rate of change of magnetic flux is nothing but the, magnetic field is nothing but the EMF. Due to that EMF only we got this magnetic field. I hope you are listening. So that's why, so what I am saying is the total magnetic field is always, this is possible only when, B in superconductor adjust itself such that B total is quantized. I don't know how many of you remember that B total is nothing but H by 2E, and we will say that is called fluxon. What is the amount of flux coming out of this? This is the total, and this we call it as fluxon. So what is this fluxon? H by 2E. It's quantized. Actually, NH by 2E. The total magnetic field is quantized, and that magnetic flux, the total flux is equal to NH by 2E. And this 2E is called Cooper pair. This 2E is nothing but what? Cooper pair. And what is a Cooper pair? Let us see. Come on. So fluxon, that magnetic, total magnetic field is quantized, means the flux is also quantized, and what is that value? Nh by 2e. So don't forget, that is word called fluxon. And what is that 2e electrons indicates in the denominator? That is the Cooper pair. Right. So earlier, from the isotopic effect, we made a statement. Please observe that carefully. It gave some evidence that there exists an interaction between electron and phonon, and electron and a lattice. So this is very, very important. Please wait. Right. Are you ready? Right. So the last one. So here we are discussing this superconductivity, and finally what we understood, the one of the reason for the superconducting behavior is the interaction between electron and phonon. How they are interacting? Because in a lattice, if you consider, at one corner one electron is there, and far away one more electron is there. How these two electrons are interacting? How those two electrons form a pair, that is called a Cooper pair, and what is the mechanism in that? Let us discuss. Are you ready? So this is the, I think, Nobel lecture, I think, means they got Nobel Prize, no? Yeah, BCS theory. So I think 3 scientists, what are those? Bardeen-Cooper-Schrieffer, right. These are the 3 people who got Nobel Prize, I think. Okay, ready. So what is this BCS theory? Forget about this one. Let us please imagine this classroom. Now this is, let us say, lattice. Okay, so in the lattice we have lattice points. At each lattice point you have, let us suppose, positive ion core. Positive ion core means wherever you sit, in that place is nothing but a positive ion core. What you are? Electrons. Let us suppose you are all electrons. Ready? Yeah? So where you occupy? Positive ion cores. That means wherever you occupy, that place is called positive ion core. Try to understand. Okay. Now that is one of the electron. She wants to send a message to that girl. Okay? She wants to send a message to that girl. Then how they will send? SAR is there. So what that electron will do? That electron will push the other person. That means other person means other location. What is that location? Lattice site. So the electron which is beside a positive ion core, what this electron will do? This electron will attract towards this positive ion core. That means it will push like this. Then that person will push this person. This person will push like that. That means what will happen finally? That girl will see that girl. Over. So those two people have already interacted. If you observe carefully, that electron and this electron both are having what kind of Coulombic force? Repulsive Coulombic force. But in this lattice, what is happening? They are interacting with what? That electron is disturbing the lattice. That first electron is disturbing the lattice. How? It is attracting the next lattice site, the next positive ion core. Then it is disturbing the positive ion core. Then the entire lattice will be disturbed. So that electron is disturbing the entire lattice. Then the lattice vibration started. Then what you will get? Phonons. So those two electrons are interacting with phonons. Then what kind of interaction it is? Attraction. Sir, how do you know attraction, sir? Otherwise, how you will say pair, sir? When pair will be formed, sir? Attraction. If repulsion is also, pair will be there, diverse will be there. So, how the pair will be formed means what? Attraction is there. But sir, already repulsive force is there. Yes. That attractive force is dominating over repulsive force. Where, sir? At low temperature. Where, sir? At low temperature only. That's why this BCS theory can explain superconductivity at low temperature. This can explain only type 1 superconductivity, not type 2 superconductivity. Only type 1 superconductivity. What is that? Soft superconductivity. So once again, wherever if you consider a lattice, you will consider one electron. How this is interacting with an electron which is far away? First electron is disturbing the lattice. How? By attracting the positive ion core. Okay, it's a side near, very near. So it is attracting towards the positive ion core. Then the whole lattice, what happened? Disturbed. Due to the distortion in the lattice, we are getting phonons. And these phonons are getting throughout the lattice. And that two electrons are interacting with what? Phonons. They already confirmed. There must be some interaction between electron and phonon. So like that, although these two electrons are having a repulsive force, still they are able to form like a pair. Okay, how they are forming a pair means the attractive force is dominant than repulsive force. That too weak. Why it is at low temperature? This is possible all at a low temperature. So the BCS theory can explain superconductivity at low temperature. At low temperature. 1 second. And this can explain only type 1 superconductivity. Type 1 superconductivity. It can't explain type 2, only type 1, which is very soft or very, that is called a low temperature superconductivity. So ready. So they explained this by this formation of Cooper pair. So what is this Cooper pair? The two electrons which are separated by a large distance, can interact through phonons. Are you interested? I'm not getting any voice. Already explained now. To interact through lattice vibrations. In the interviews, they won't ask to derive that and this. They will ask, what is a Cooper pair? Electron repulsive na, how you got pair? Then you have to say this. Ayya, lattice vibrations. This lattice vibrations, quanta of energy, quanta of vibration is nothing but what? Phonon. So finally what happened? I am considering a lattice. Listen, again I am trying to explain. And here is one electron. This is the positive ion cores. At each lattice point you have positive ion cores. Okay, we have electrons everywhere, free electrons, because it's a conductor, like that. So what is happening? If you consider this electron and this electron, these two are very far away. These are very far away electrons. Say yes or no? But still they are going to form a pair. How they are going to form a pair? Listen, this electron exert an attractive force. One minute. Exert attractive force on adjacent positive ion core. So because this is the electron, adjacent to this we have some positive ion core, definitely there exists what? Attraction. So this electron attract this positive ion core. Then what will happen? The lattice will be disturbed. Once the lattice is disturbed, that disturbance is carried out throughout the lattice, through emission or absorption of phonons. Clear? That's it. Then what will happen? This will exit, there will be, again, the total lattice will be disturbed, phonons will be released, and this electron interact through phonons, and these two electrons are interact with phonons, interact through phonons, just like this. Here is an electron, here is an electron, both are having repulsive force. Exactly, no doubt about this. But due to the lattice vibrations, these two electrons are interacting, are sharing some energy. What is that energy? Phonons. And this is the interaction of electrons through phonons. And electron-phonon electron interaction is simply attractive, because the ion cores are positive, your electrons are negative. That's why that attraction we can say it as attractive. But what is happening here? The attractive force is greater than repulsive force. Where? That's good, that's good. At low temperature. That's why BCS theory can explain superconductivity at low temperature. That's it. And hence what happened? This electron and electron form a weak pair. Yeah, pair, but it is a weak. Bonding is weak. Okay. If you increase the temperature, it's gone. That's why it is only possible at a low temperature. And once it form a pair, one total spin, one is a plus half, another is a minus half, one is up, another is a down, spin up and down. That's why here the total spin equal to 0. And if you consider the k vectors, one is a plus, another is a minus k. That's why combination of these two will give the net k vector is also equal to 0. The Cooper pair properties, net spin 0, net wave vector is also 0. Okay, and that's why they behaves like nobody is saying, means you are not listening. S is equal to 0, they behaves like S is equal to 0, they behaves like bosons. So electron Cooper pair is a boson. They obey Bose-Einstein statistics. That's it. It's a weak pair, and if you increase the temperature, that bond will be spoiled. If you want some more information, you can just go through that textbook. Just I have given how the pair is formed, Cooper pair. So fluxon, magnetic field fluxon, that is NH by 2e. So that 2e is nothing but the pair of electrons, that is called Cooper pair. And all these are related to the superconductivity nature or something like that.